Hey guys, Mr. McKinney here, just going through how to guarantee that you'll get a 5 on the AP exam, which you guys are going to be taking on Monday morning. So remember, the exam is Monday morning, May 9th, 2022. 7:30 a.m. is when you need to be getting to school, and it will be in the 1100 cafeteria. All right, let's get started. So, the easiest way to get a guaranteed 5 on the AP exam is to, drumroll please, answer all the questions correctly. So I can't guarantee that you'll get a 5, but I do want to go over some tips and tricks before you guys take the AP exam. So first of all, the format of the exam. We've talked about this in class, but just to go over it one more time. You'll be doing the multiple choice questions first. The non-calculator portion will happen first. You'll have 30 questions in 60 minutes. That's about 2 minutes per question. You're likely going to run out of time if you don't pace yourself very well here. So make sure you're keeping an eye on the clock. If anything's taking you more than 2 or 3 minutes, maybe skip it and come back to it later. The second part of the multiple choice is when you are allowed to use a graphing calculator. Please bring yours if you have one. We'll have some extras, but not enough for everybody. It's 15 questions in 45 minutes, so it's about 3 minutes per question. This is the one section where you might have a little bit of time left over. You still need to focus on pacing yourself, but this is the one section where you might have a little bit of time left over. There's no penalty for guessing, so make sure you don't leave any of them blank. You have at least a 25% chance of getting it right if you guess, so make sure you've answered all the questions. After you take this hour and 45-minute portion of the test, there will be a 10-minute break or so you can eat some snacks, you can drink some water. And then the second half will be the free response portion. So you'll have the first 2 questions. You're allowed to use your graphing calculator. You'll have 30 minutes. So that's about 15 minutes per question. You have to pace yourself. Nobody's going to tell you to move on after 15 minutes. Once the 30 minutes is up, you'll immediately go on to the 4 non-calculator questions. You have an hour for those, roughly 15 minutes each again. So same time limit per question for both of these parts. Now, you are allowed to go back to part A and keep working on it if you happen to finish part B early or you just want to, but you'll no longer be able to use your calculator. So you might be able to go back and say that the total distance is the absolute value of velocity, take the integral. You might be able to write this down. You wouldn't know what it was equal to, but usually you'll get a point for this part and then another point for the answer. So you could at least get the setup point. All right, so let's start going through some of the tips and tricks that can help you make sure you maximize your score. First of all, show all of your work and do it as concisely as you can. So if I wanted to find the average velocity of this is the correct answer. I may get 1 point, I may not get any points, depending on how the AP decides to grade it each year. I need to show that I knew what I was doing. I need to show the calculation that I did. So you can either write the average value formula with the entire formula plugged in, or you can just put in V of t. And this is what I would recommend that you do, because if you accidentally copy something wrong, it's now incorrect. Keep in mind, average velocity, if you're given the velocity function, you want to use the average value, 1 over b minus a, integral from a to b, v of t dt. If I asked for the average velocity and I gave you a position equation, then we would be doing a slope calculation on the position. So average velocity depends on what they give you. If they give you velocity, do an average value calculation. If they give you position, then you would do like x of b minus x of a over b minus a to find the slope of position, to find the average velocity. Make sure you're in radians. So if you're in physics, you might be switching back and forth. Make sure you're in radians. If you're worried about it, just hit second plus 712 to reset your calculator before you start, and you will default to being in radians. Unless they explicitly put degrees in there, which is extremely rare, you should be in radians. Make sure you don't round until the end of the problem. So let's say we were trying to figure out this problem, and we figured out that B was 13.2354. Now, some of you guys are going to remember that we need 3 decimal places, so you're going to ignore this 4. But you need to make sure you don't round until the end of the problem. You get a slightly different answer. You will not be accurate to the point you need to if you round too early. So make sure you keep all of the decimals until the end of the problem. And now I can round to my 3 decimal places. We always need 3 or more, so never round it to less than 3. 3 or more, it's okay to put more than 3. And if you have decimals during the problem, either keep 4 or 5 decimals, or better yet, store it in your calculator using the store button. You can get points on part C even if you don't get parts A and parts B. So for example, if we had some crazy stuff going on in part A and part B that we don't know how to do, and then we get to part C and we're like, oh, I know the integral of 2x is just x squared evaluated from n to n. So we do n squared minus m squared. Make up a guess for parts A and B. So go back to part A and say n equals 3.27 or pi over 4, whatever you want. And then m equals 3.2. Maybe don't make them too hard, but go in and make guesses, and then you can still get points on part C. Make sure you're showing what you're doing on the calculator. So even though this is an incorrect answer, you can get some points because you showed what you were doing. You showed that you took the derivative of x squared plus 2 to the x. So if we're trying to find the derivative, now you can write it like this, or you can even just say that f prime of 4 equals 96.988. My understanding is that as long as you show the connection, you could still potentially get some points. Now, if you wrote down the correct answer, but you didn't show how you got the correct answer, you might not get any points, depending on how it's graded that year. And a really common thing that you're going to want to show is the relationship between position to velocity to acceleration. So if a question gives you a velocity and it asks for an acceleration at, say, t equals 3, or let's pick a different number, t equals 4, then we would want to say that a of 4 equals b prime of 4. So make sure you know the connection. So this is the easiest way to show the connection. This is a pretty easy problem, 3. But just make sure you're making this connection. Show the connection between acceleration and velocity. We all know that if you start with position and take the derivative and get velocity and take the derivative again, you get acceleration. The AP reader doesn't know that you know that, so make the connection. If you do make a mistake, don't worry about erasing it. Like A, it might get really ugly. B, it takes too long. Just cross it out. Whatever you don't want them to look at, just cross it out. They're not allowed to score something that's crossed out. Now, if you run out of time and you know your answer's wrong, but you don't have anything better to do or you don't have time, leave it. It might be worth something. It may not get you all the points, but it could be worth something, and you don't want to leave it blank. So don't cross it out if you don't have something better to do, but cross it out rather than erasing. You can use your calculator to graph a function to find the derivative at a point. This is Math 8. Or find the value of a definite integral. This is Math 9. Or solve equations. The easiest way to do that is graph both of them and then find out where they intersect. So you can use your calculator to do those things. What you don't want to use your calculator for is to find a max and a min by looking at the calculator. So if my graph looks like this, I can't use the calculator function to find this point. The way I'm going to find a max or a min is I'm going to talk about f prime either going from positive to negative or from negative to positive, depending on whether I'm at a max or I'm at a minimum. So make sure you're justifying these types of things with calculus, not by looking at a graph. So concavity, I don't want to look at the fact that this is concave down. I want to look at the second derivative. Inflection points, I can't just look at it and look for where it changes concavity. I need to look at the second derivative. Increasing and decreasing, I should be looking at the first derivative. For domain and range, you'd be looking for where the original function might be undefined. So you're looking for square roots of negatives. You're looking for dividing by 0. Those are issues that would cause your domain or range to not be unlimited. The calculator can help you verify that you did it correctly, but you can't say I looked on the calculator and found the max was 22. You have to say f prime changed from positive to negative at x equals -2, and then show the work that when you plug in -2, you get positive 22. You can do arithmetic, but you don't need to, and I recommend that you don't on the AP exam. So if we look at this problem, there's 3 different ways we could have done it. Or 3, like they're all the same thing. The integral of 1 over 2 root x is root x. We'd have to rewrite this. If you recognize it, you can save yourself some time. So if I write root 48 minus 0, and I say it's root 48, and then I simplify it to 4 root 3, that's fine. This is the best answer that we could get. But we don't need to. We can just leave it as the square root of 48. That is worth just as many points as 4 root 3. Now, if you do simplify it, you would have to be correct. So we would lose a point or not earn the last point if we mess up while we're simplifying it. So don't worry about simplifying on a free response question. Once you have plugged in all of the values, you can just box it. Don't worry about trying to simplify. You can, but it's not worth anything. Make sure you've answered the question. So a lot of times when we ask about a minimum, students will find out where it happens, but not actually answer the question. So to find a minimum, I'd want to look at f prime, want to find out where it's equal to 0, and find that x value. So students mistakenly will stop here and say the minimum is x equals 1. The minimum will happen when x is 1, but I need to plug 1 back into the original function to actually find the minimum. The minimum, max, and min are y values unless it explicitly asks for the x value where something happens. When you're trying to justify your answer, think about what you need to justify. So for example, if they ask you to justify a point of inflection, make sure you've showed the sign change, not just that the second derivative was 0. Whoever's grading your exam is a human. Try to make it as easy on them as possible. Be as neat as possible. Try not to jump all over the place. If you do, show arrows to show where they should go. And make sure you box your final answer. If you don't box something, they may just look at the bottom rightmost thing you have and assume that's your answer. So make sure you circle or box your final answer. So here are some student errors we're going to go over real quick. So one thing is students think that if the derivative is 0, that means we have a local max or min. Maybe. We need to check for a sign change. Same idea with the point of inflection. If the second derivative is 0, we might have a point of inflection, but we need to make sure there is a sign change. So make sure you're always checking for a sign change on local max or min or on points of inflection. Average rate of change, none of my students would ever make this mistake because we all know that average rate of change is always going to be a slope calculation. Don't average the 2 slopes. That will never be the correct answer. Do a slope calculation for average rate of change. And make sure you show that slope calculation. For the washer method, a really common mistake is to subtract the 2 radii and then square it. Remember that we're adding up washers. And the way to find the washer is the big circle minus the little circle. And so we need to do pi big R squared minus pi little r squared. We don't want to square them together. So make sure you square each of them individually. You can pull the pi out or do it the way that I would have taught and leave the pi in. This is a really important one. Make sure you separate the variables on a differential equations when you're finding the particular solution. So in this case, we'd cross multiply. We get y and dy on one side, x and dx on the other. Make sure the dy and the dx are on the rightmost thing on each side. You don't want to write dy y, because then when you integrate it, you're integrating this, and then you just have a y left over. So dy and dx should be at the end. And then don't forget to do plus c if it's an indefinite integral. If there's limits, you don't have to worry about c, but on an indefinite integral, you need plus c. Don't ever say it. Be very specific. Say f prime, say g, don't say it, because we don't know what it is. It could be a giraffe. All right. Chain rule will show up all over the place. So if there's an inside function and an outside function, remember to take the derivative of the outside function first and then multiply by the derivative of the inside function. A couple last minute things. Make sure your calculator's ready. Bring extra pencils. Bring your ID. Bring a watch. Store your stuff the night before if you can. Be healthy. The cheat sheet will not be allowed. Water and snacks may be allowed. Good luck. I believe in you guys. You're going to do great.